Hello, good evening everyone. Welcome to BYJU'S exam prep. So let me know once I'm getting the voice or not. Okay. So the voice is clear or not? Yes. So according to me, the voice is perfectly fine. Yes. So good evening everyone. Welcome to BYJU'S exam prep. And we are bringing a new series for all of you guys where we are going to discuss about the basics of signals. And in this particular series that is named as BYJU'S Premier League, we are actually connecting the YouTube session with our app. That means in the YouTube, we will be discussing some important concepts, and related to those concepts, the questions will be discussed in the app, because in the app we have the option of polling. So there will be a four option for you, and those four options, according to that, the MCQ will be provided, and you can see the leaderboard itself where you are standing. So this is Saket Verma, and I'm having more than 11-year experience or 12-year experience for teaching the GATE and ESE, and the qualification is IIT Guwahati से मैंने M.Tech किया हुआ है, and I have cracked the different PSU exams, and my area of expertise are these subjects. So as you know that this is the BYJU'S Premier League where we are going to discuss about the YouTube plus app series, and that means the combination of both. So we will be having very good quizzes in these particular topics that we are going to discuss in the YouTube. So before starting the session, let me tell you that there is a very good session held today, and you can go and watch the this recorded session of this particular workshop on held on the 20th June today at 7:30 p.m. So let's start with the signals. What is the signal? So you know that the signal is a physical parameter which we discuss, or which we see according to the time. Okay, so what are the changes in that particular parameter according to the time that we observe? So signal can be divided into the analog and the digital, where in the analog we have the continuous time signal and the discrete time signal and the digital signal. So continuous time signals are those signals which are continuous in the time and continuous in the amplitude both. So the continuous means that is continuous in all the time. And what about the continuous time signal? So, but continuous time signal can also be the discrete in time but the continuous in amplitude. So continuous time signal is continuous in time but discrete in amplitude. That is, after sampling the signal which you get are known as discrete in time. Okay, so continuous in time and discrete in magnitude it is saying. So it is like this. Okay, so this is the continuous in time actually, not in the amplitude. So it will be like this, like a square wave. This is the continuous in time because it has the value for all the time, but it is having the finite value in time. So like in the amplitude. So like it is having the plus 5 and minus 5. This is y of t and this is t. So this is valid for all the time, and but in the magnitude it has only two values, that is 5 and minus 5. So that is why it is known as discrete in magnitude. Now discrete time signal, that means after sampling which you get. So discrete in the time axis but continuous in the amplitude. So that means the signal which we get in this form. Suppose we have the signal like this, and if we remove some part, that is continuous in magnitude but in time it is discrete. So it is, you are getting the values only in this particular time. So that is known as discrete in time. Okay, so that is at t equal to 0, n equal to 1, 2, and means in the multiple of ts. So here we will replace t is equal to nts, and we will get the signal which is discrete in time. Now coming to the next part, that is the digital signal. The digital signals are those signals which are continuous in both magnitude and time. So these are the basics of the signals, where we have the four type of signals. But basically, this is just the brief about the signals because I am waiting for the students to connect. But the important part which we are going to discuss is the operation of the signals which we apply on the signal. So the first thing that we know is the amplitude scaling. So how do you perform the amplitude scaling? How do you perform the amplitude folding? How do you get the time shifting, which it is the right shifting, it is the left shifting, it is the signal scaling, that is compression and the expansion. So signal may get compressed, signal may get expanded, and the time folding. So these are the basic operation which we perform on the signal, and based on this particular topic, we are going to get the questions on the app. Okay, just right after the 30 minutes at exactly at the 9 p.m. we will have the session on the app. So what is the amplitude scaling? So how do you perform the amplitude scaling? So the mathematical representation of the amplitude scaling, that means the signal x of t is there, and if you want to perform the amplitude scaling, so after the amplitude scaling it will become a into xt. So a into xt is the scaled version, amplitude scaled version of xt. What is the working rule for this? How do you get the amplitude scale signal? So signal x of t is simply multiplied by the amplitude scaling factor a. So in the amplitude scaling operation, width of the signal remains unchanged, only the amplitude gets altered. So the meaning of this particular point we can see with the example. Suppose you are having the signal x of t. Okay, suppose you are having the signal x of t having the amplitude 2 and the width 4. This is the time axis. Okay, now suppose you want to draw xt but multiplied with 5. So if you want to draw the 5 of xt, so what will be the 5 of xt? So as I said that the working operation is saying you have to multiply only in the amplitude, not in the width. So width is not going to alter. That means the width is going to be same. So the previously the width was 4. Now also the width will remain same as 4. But the amplitude which is 2, now this 2 will multiply with the factor which you have written in front of x of t. So by the factor a, we said that we want to apply the amplitude scaling by the factor a. So this 2 you are multiplying with the factor a, where a is 5. So you are going to get the amplitude as 10. So the amplitude will be 10, right? Now if I talk about the area, so what is the area of this signal? Area is simply 2 into 4, that is the rectangular pulse. So we are getting the area as 8. Now you can see the area of the new signal which is amplitude scaled, which is 10 into 4. So this is 40. So you can say that if x of t has the area A, okay, let us suppose the x of A, this is has the area A, then k times of x of t has the area k times of A. Okay, that is k times of A, because the area was previously 8. Now the amplitude scaling factor is 5. So it is actually scaled by the factor 5. So that is nothing but the amplitude scaled version of x of t, where the area is also increased by the same factor. So the area is also increased by the factor 5. So the if you multiply the signal by k without changing the width, that means the area will also change by the same factor k, right? Now coming to the amplitude folding. So the amplitude folding means mathematical representation of amplitude folding. X of t is amplitude folding minus of xt. So here what we have done, we have taken the amplification factor or amplitude factor as a minus 1. So what will happen in this case? What will happen in this case? If you will just see by the example. Okay, so this is t, this is x of t. Okay, the same signal we will take. Okay, so suppose this is 5 and this is 3. Okay, now you can see that we want to draw minus of xt. So minus of xt means, wait, okay, so suppose this is 5, this is 3. So we want to draw minus of xt. So the amplitude is multiplied with minus 1. So because the amplitude is multiplied with minus 1, this will shift towards the negative side. So the amplitude, this 5 is now 5 into minus 1. You have multiplied with the minus 1. So here your amplification factor is minus 1. So the result is minus 5. Width is not going to change. So in any type of amplitude scaling, whether you perform the amplitude folding or whether you done the amplitude scaling, the width is not going to change. You have to just change the magnitude of the signal according to your amplification factor, according to the value of k. Now, if I talk about the area, area is 5 into 3, so that is the 15, and area here is minus 5 into 3, so that is minus 15. So here you are getting the area is minus 15, and you can say that if you take the mod of it, because you usually say the area is not negative, so the area will also be 15. But whenever the sign is given, whenever the sign is given in the option, you have to take the sign also. But usually they don't give you the negative sign whenever the calculation of the area is happening. But if they give with the minus 15 and plus 15 both in the option, then we will consider the minus 15 as a correct answer. Now coming to the time delay and time advance. Time delay means what? Time delay means after some time. Okay, like suppose this is our x of t, or any signal at any time t is equal to right now 8:30 p.m. So suppose you planned of watching this video at 8:30 p.m. but because of some reason, maybe some other classes, or maybe because of your project work, maybe because of your college work, maybe because of your job, you joined this session after some time. That means at 9 p.m. suppose. That means you are delaying this class, means you are delayed in this class by the 30 minutes. Okay, so the class started at 8:30, but because of some reason you delayed the class, means you delayed to join the session, and you joined the session at 9 p.m. That means if I have started what my session at 8:30 and you are joining at 8:30 9 p.m., that means this is shifted towards right. So whenever we talk about the delay means right shifting, because whenever you delay the time, it will increase. So that means it will go in the positive side. So delay means right shift. Okay, suppose I am starting the video at 8:30 and you have come early because you are excited about this class and you have joined the session at 8:25 p.m. That means you are already in the waiting that the session will start and you will attend and join this particular session. So that means it is the advance. You are joining the session in advance. So advance means left shift. Advanced means left shift. Sir, which subject to start in Gate 24? INEC, Rishi Joshi. If you are Gate 24 aspirant and you are from instrumentation, Gate Vision batch is already started. Okay, only Gate batch is already there. We are starting very soon from the 23rd of June, and some batches are already started. And Rishi Joshi, 30 minutes delay. Yes, 30 minutes delay. You are from EC. Okay, that means in. If you are from EC and you are preparing now for the first time, then obviously you have to start with the basic subjects like network, or you can also start with signals. Okay, these two subjects you should start with. Any one of these two subjects you can start, and along with that you can take as a supplementary subject as an apti or mathematics. So one technical subjects and one non-technical subjects you can run together. So 12 marks is very less actually, Rishi. So you should start preparing from the beginning. So I think you should start from the network or the signal along with any basic subject, any non-technical subject like FT or maths. So two subjects at a time you have to start from now, and gradually once you get a command, you have to go into the three subjects at a time because now the time is less. So in the 6 months, maybe sometimes if you attend any classes, you have to go through the three subjects also. Yes, that is helpful. If you are looking for the placement also, then the aptitude will obviously helpful because in aptitude you will have the reasoning also and English also. So it will be helpful in the campus placement obviously. And network is the basic subject. So to learn any advanced subject, you have to understand the network and the signals. Okay. Now the time delay, as I said that the time delay means it is shifting towards right. So when will we shift towards right, it will be denoted as x of t minus a. X of t minus a would be the shifting towards right. And to delay the signal x of t by a, argument t is replaced by t minus a. Okay, that is the working rule. And time delay means shifting right on the graph as I told you. And time delay means to start late as I told you that if I am starting the session at 8:30 and you are joining at 9 p.m. that means you are starting late. That means you are delaying that. That means you are right shifting. Good evening, Arya Prasad. So you can represent any signal, suppose x of t like this. This is minus 2 and suppose this is 3 and the amplitude is suppose 4. This is x of t. Now you want to delay the signal. Okay, now you want to delay the signal by 3. Okay, this is t minus 3 you want to draw. So as you can see that this x of t is represented as 4 where t is in between minus 2 to 3. Okay, and 0 otherwise. So if you want to draw x of t minus 3, so x of t minus 3 according to the working rule what we said that t should be replaced by t minus 3. So t should be replaced by t minus 3. So this t should be replaced by t minus 3 and this will be a minus 2 to 3. So it is minus 2 to 3. So it can also be written as minus when you add both the side by 3. Okay, if you add 3 both the side, so this will be plus 1, this is t and this is 6. Okay, so we can write this particular as minus 2, this 3 we are adding both the side means all that we are adjusting this 3 and we are adding 3 in all the x's, so minus 2 plus 3 become 1, minus 3 plus 3 becomes 0, 3 plus 3 becomes 6 and 0 otherwise. That means it is showing that with the signal which is starting from minus 2 and ending up to the 3, now it is starting from the 1 and ending up to the 6. So it is 1, 2, 6. Now width is not changing. The previous width was same. The width of this particular pulse was 5. And now if you calculate the width, that width is still 5 and the height is also same. So that means the shifting does not affect the area of the pulse. Shifting the signal, shifting the signal does not affect area of the pulse. Okay, you can see that the area, if I am calculating here, it is 4 into 5 which is 20 and area I am calculating here is again 4 into 5 is 20. So area is not changing. So when I am delaying the signal, the area is not changing. Yes, Rishi, correct. 1 to 6. Now, how do you shift the signal towards left? So the rule is same. You have to replace the t by t plus a. The mathematical representation of the time advance operation is x of t time advance, that is t plus a. So you have to replace the t by t plus a. Time advance means the left shifting. That means you are starting early. If you are starting early something, that means you are advancing that. So if I will ask you to draw this particular signal, then how will you draw? Minus 3, this is 1, and this is 5. This is x of t. Now tell me, how will you draw t plus 2? X of t plus 2. You have to draw the signal x of t plus 2. This value is 5. Okay. So in the previous example, we have seen that in the previous example, if we delay the signal, that means we equate the argument to 0 and we added the 3 in all the x's. To get this, we added the 3, we added the 3, we added the 3. So we got 1, t and 6. Similarly, here we have the t plus 2. So t plus 2 equal to 0. That means t is equal to minus 2. So t is equal to minus 2. That means you have to add minus 2 in the whole axis. So if you add minus 2, that means it will become minus 5. If you add minus 2, that means it will become minus 1. If you add minus 2, that means it will become 3. So the signal will start from minus 5. The signal will start from minus 5 and it will go up to 3. Okay, so signal is starting from minus 5 and it will go up to 3. So this is the value of x of t plus 2. So if you will draw the signal x of t plus 2, it will look like this. Okay, so this is the left shifting. With respect to this, the signal is shifted towards left. So advanced operation means left shifting. Okay, advanced operation means left shifting. And whether it is a right shifting or left shifting, it does not affect the area of the pulse. Okay, so whether it is a left shifting or right shifting, it does not affect the width of the pulse. Okay, that is the 2 point that you should know. Now, how do you draw the signal which is given in this form? How do you draw the signal which is given in this form? Cos of AT plus B. How do you draw the signal which is given in this form? Cos of AT plus B. Can you tell how will you draw the signal which is given in this form? How will you draw the signal which is given in this form? So the step 1 is assume the coefficient of t as 1. Assume the coefficient of t as 1. Okay, that means you have to simply draw x of t. Okay, that is draw x of t plus b. Then scale by factor a. Okay, then scale by factor a. That means after scaling you will get x of a t plus b. Or you can also say that you have to perform drawing the signal from the right hand side. Okay, or simply we can say that simply uh, take start drawing from the right side. Start drawing the waveform from right side. Okay, that means you have to consider x, forget about a. What is b? Plus b is written. It may be plus, it may be minus. So if it is plus, that means advance operation, and if it is minus, then it is a delay operation. Okay. So according to the plus or minus sign, you have to perform either delay or the advance. And after performing that, you have to consider the scaled version, that is x of 80 plus minus b, scale by factor 80. So without thinking of these two things, just start drawing the waveform from the right hand side. You will get the signal. So now the signal expansion and the signal compression. So mathematical representation of the time scaling is x of 80. If you want to draw x of 80, then take the coefficient of t and divide the whole axis by factor a. Or you can simply replace the t by 80. And time folding also, you have to just take the value of a as minus 1. Okay. So like this. Suppose I have this signal. Okay, this is 0, this is 1, this is 2, and this is also 1. This is x of 80, x of t. And suppose you want to draw x of 2t. Okay, so what is the coefficient of t? The coefficient of t is 2. So because since the coefficient of t is 2, just divide the whole axis by 2. You will get 0 divided by 2 means 0, 1 by 2 means 0.5, 2 by 2 means 1. So whatever signal was present at 0, now it will present at 0. Whatever signal was present at 1, now it will present at 1 by 2. And whatever signal was present at 2, now it will be present at 1. So in this way, you will get the signal which is in the expanded form. Okay. So now guys, the session will be continued in the BYJU'S exam prep app. The link is given in the comment section. You can directly join and let's start solving the questions whatever we have discussed over here.